Hello and welcome everyone. I'm Dr. Pragya Sharma from ABS Engineering College, Ghaziabad. This is lecture number 5 of this video lecture series of Fundamentals of Mechanical Engineering. We are covering Unit 4 Introduction to Fluid Mechanics and Applications in this lecture series. We have covered few topics in previous lectures. So, now the topic we are covering in this lecture is hydraulic pumps. What are hydraulic pumps? These are the devices are basically designed to convert mechanical energy into hydraulic energy. They are used to move water from lower points to higher points with the required discharge and pressure head. We generally seen pumps installed at our homes to get the water from lower point to higher points with the required discharge and pressure heads. In the syllabus, there are two types of pumps are included in AKTU syllabus. One is centrifugal pump, and the another one is reciprocating pump. These two pumps are covered in this lecture. So, what is centrifugal pump? If the mechanical energy is converted into pressure energy by means of centrifugal force acting on the fluid, this type of hydraulic machine is called centrifugal pump. Here is the diagram is given for centrifugal pump. The centrifugal force is used to convert the mechanical energy into pressure energy. That is why it is called centrifugal pump. First, we will discuss the construction part of the centrifugal pump. So, construction include there are various parts which includes in this centrifugal pump. First is impeller. The impeller is the rotating part of a centrifugal pump, which is called impeller. Here is this impeller, the rotating part. It consists of a series of backward curved vanes. The impeller is mounted on the shaft, which is connected to the shaft of an electric motor. Here is the shaft, and the vanes are attached on this impeller. Second is casing. The casing of a centrifugal pump is similar to the casing of any reaction turbine. It is an airtight passage surrounding the impeller and is designed in such a way that the kinetic energy of the water discharged at the outlet of the impeller is converted further into the pressure energy before that water leaves the casing and enters the delivery pipe. This is the casing, which is enclosed, which includes the impeller part. Next is a suction pipe with a foot valve and a strainer. Here is the suction pipe. This is the suction pipe from where the water is sucked from the base level. Uh, this also had a foot valve and a strainer. So a pipe whose one end is connected to the inlet of the pump and other end dips into the water in a sump is known as suction pipe. The one end is connected to the inlet of the pump. This is connected here, and another end is dipped in the sump with the foot valve and the strainer. A foot valve, which is a non-return valve or one-way valve type of valve, is fitted at the lower end of the suction pipe. The foot valve opens only in the upward direction. A strainer is also fitted at the lower end of the suction pipe so that the dirt part can be strained there. The next part is delivery pipe. A pipe whose one end is connected to the outlet of the pump and other end delivers the water at the required height is known as delivery pipe. This is delivery pipe. One end is connected at pump outlet and another end is at the delivery location. The other is suction head. It is the vertical height of the center line of the centrifugal pump above the water surface in the tank or pump from which water is to be lifted as shown in figure here. This is HS, suction head. The vertical height from the center line of the centrifugal pump above the water surface. This height is also called suction lift and it is denoted by HS. Then delivery head. The vertical distance between the center line, the vertical distance this between the center line of the pump and the water surface in the tank air and the water surface in the tank to which water is delivered is known as delivery head. This is denoted by HT. Then static head, which is denoted by HS or capital H. The sum of suction head and delivery head is known as static head. This is represented as HS or in capital H or as capital H. HS is equal to suction head plus delivery head. This is the construction part of the centrifugal pump. Now, the question is how the centrifugal pump works to lift the water from a lower end to the higher end. So, the centrifugal pump acts as a reverse of an inward radial flow reaction turbine. This means that the direction of the flow is outward radial direction. This means that the flow in centrifugal pump is in radial outwards direction. The centrifugal pump works on the principle of forced vortex flow, which means that when a certain mass of a liquid is rotated by an external torque, the rise in pressure head of the rotating liquid takes place. The liquid is rotates here by using external torque. That is why the water rises. So, the rise in pressure head at any point of the rotating liquid is proportional to the square of tangential velocity of the liquid at that point. That means the rise in pressure head is equal to V square by 2G. Thus, at the outlet of impeller, where radius is more, the rise in pressure head will be more, and the liquid will be discharged at the outlet with a high pressure head. From here, the liquid will be discharged. Due to this high pressure head, the liquid can be lifted to a high level. The water is lifted from the low level to the high level. So this is the working of centrifugal pump. Some advantages of centrifugal pumps are like the most significant advantage is the simplicity of this pump. They are very suitable for large discharge and smaller heads. The pump allows them to run at high speeds with minimal maintenance. Their output is very steady and consistent. There are very less frictional losses. Some of the disadvantages are also there. These pumps always face cavitation problems. Cavitation occurs when the pressure in the pump drops below the liquid's vapor pressure. It causes the bubbles to form in the liquid. So they are having this cavitation problems. They cannot be able to work with high heads. During pump operations, there may be a possibility of misalignment of the shaft. These pumps are not built to operate with highly viscous liquids. These are few disadvantages of centrifugal pumps. Now, where these centrifugal pumps can be used, these pumps are popularly used in domestic applications like pumping water from one place to another. They are also used in refrigerant and cooling recirculation. This pump is also used for drainage, irrigation, sprinkling. These are also used in gas and oil industries like pumping for slurry, mud and oil. They are valuable for sewage systems also. Now the another pump we are going to study is reciprocating pump. These are if the mechanical energy is converted into pressure energy by sucking the liquid in a cylinder in which a piston is reciprocating backward and forward, which exerts the thrust on the liquid and increases its hydraulic energy or pressure energy. These type of hydraulic machines will be termed as reciprocating pump. These are using the reciprocation of this piston. Here is the piston is attached. The reciprocation of this piston forward and backward direction. This backward and forward direction. Due to this, it exerts a thrust on the fluid. Here is the suction pipe. Here is the delivery pipe. So the reciprocation motion of this piston exerts a thrust force on this fluid, which is sucked from the sump level, and this increases increases the hydraulic energy or the pressure energy in the liquid, and this type of machines are called as reciprocating pumps. So first we will be discussing the construction of this reciprocating pump. There is a plunger or piston. Here is the piston attached. This is the piston. The reciprocating pump has a piston or plunger, and it reciprocates in the cylinder, due to which suction and increase in pressure takes place. And second one is piston rod. The piston rod connects the connecting rod. This is piston rod. Here, this is piston rod. It connects the connecting rod to the piston and transfers reciprocating motion to the piston from the connecting rod. Next is connecting rod. This is connecting rod which is connected to piston rod. The connecting rod is used to connect the piston rod and crank. Here is the crank. This is crank. The crank is connected to prime mover, which may be an electrical motor of an engine. This crank is then connected to the connecting rod as shown in the figure here. This is crank is attached to the connecting rod. Further, this connecting rod is connected to the piston rod. Then the reciprocation motion is given to this piston. So the rotary motion of the crank is converted into reciprocating motion of the piston rod. Next is suction pipe. This is suction pipe. It is the pipe that connects the reservoir to the inlet cylinder of the pump. Next is delivery pipe. This is delivery pipe. Here, the delivery pipe is used for delivering the pressurized liquid coming out from the pump to its destination. Then there are suction and delivery valves are attached. Suction valve is attached at suction pipe. Delivery valve is attached in delivery pipe. Here, these are non-return valves and allow the liquid to enter from one direction only. One valve is fitted at the inlet of the cylinder, where this is one valve inlet of the cylinder, where another one is at the outlet of the cylinder is attached. This ensures that the water or the liquid doesn't flow in backward direction. Then a strainer is attached at the beginning of the suction pipe. Here is a strainer is also attached at the beginning of the suction pipe, so as it prevents the entering of any foreign materials or dust particles in the pipe. So this is the construction of reciprocating pipe. Now we will be studying two types of reciprocating pump. One is single acting reciprocating pump and the another one is double acting reciprocating pump. The construction is same. Double acting reciprocating pump is also having piston, connecting rod, crank, same suction pipe, delivery pipe. We'll study further in this. When we are talking about the working of single acting reciprocating pump, this is the diagram given for single acting reciprocating pump. It consists of piston which moves forwards and backwards in a close fitted cylinder. The movement of the piston is obtained by connecting the piston rod to the crank by means of a connecting rod. Piston rod and crank is connected using a connecting rod. The crank is rotated by an electric motor. Suction and delivery pipes with suction valve and delivery valve are connected to the cylinders. The suction and delivery valves are one-way valves. These non-return valves are attached in suction pipe and delivery pipe. This is delivery pipe and this is suction pipe. Suction valve allows water from suction pipe to the cylinder, which delivery valves allow water from cylinder to delivery pipe only. When crank starts rotating, the piston moves to and fro in the cylinder. With the movement of this crank, the piston moves to and fro in the cylinder. So when the crank is at position A, it means at extreme left position of this piston is at the extreme left position of the cylinder. Here. Next, as the crank is rotating from position A to C, it means it will traveling from 0 to 180 degree. The piston is moving towards right, increases a partial vacuum in the cylinder. But on the surface of the liquid in the sump, the atmospheric pressure is acting, which is more than the pressure inside the cylinder. This is more than the pressure inside the cylinder. Thus, the liquid is forced in the suction pipe from the sump. As here is the less pressure in the cylinder, so it creates the suction of the liquid in the cylinder. When crank is rotating back from C to A, from C to A position, again it is traveling from 180 degree to 360 degree. The piston from its extreme right position starts moving towards left in the cylinder. It starts towards left in the cylinder. The movement of the piston towards left increases the pressure of the liquid in the cylinder, and that is more than the atmospheric pressure. Hence, suction valve closes and delivery valve opens. Here suction valve closes and it opens here, and it allows the water flow to the higher level. Then this liquid is forced into the delivery pipe and is raised to a required height. This is how this piston moves to create to increase or decrease the pressure inside the cylinder, liquid pressure. So this is the working of single acting reciprocating pump. Now when we are talking about double acting reciprocating pump, so we can see in the construction there is a major difference of pipes, suction pipes and delivery pipes. It includes two suction pipes. There are two suction pipes and two delivery pipes. So when this piston moves to and fro, simultaneously there are one suction valve is open, one delivery valve is open. So I'll describe the working of double acting reciprocating pump. It includes two suction pipes and two delivery pipes in this. In a double acting reciprocating pump, the suction and delivery strokes occur simultaneously. That was not happening simultaneously in single acting reciprocating pump. When in single acting, when suction valve is open, delivery valve is closed, and when delivery valve was open, suction valve was closed. But in here, double acting reciprocating pump, it works simultaneously. Suction and delivery strokes occur simultaneously. When the crank rotates IDC to ODC, here a vacuum is created on the left side of the piston. The vacuum is created in the left side of piston. When the crank rotates from IDC to ODC, from here like this, 0 to 180, the left position here, the suction of liquid takes place, which is through the suction valve S1. S1 opens, the liquid comes in the cylinder. At the same time, the liquid on the right side of the piston is pressed and at a high pressure causes the delivery valve D2 to open. The liquid placed here, D2 is opened. As pressure increases here, this valve is open and it delivers some liquid. It delivers the fluid present here at a raised height. This operation continues till this crank reaches to ODC. Now with further rotation of the crank, the liquid is sucked from the sump through suction valve S2 and delivered through delivery valve T1. When the crank reaches IDC, again this crank reaches IDC, here 180 to 360, the piston is in the extreme left position. Thus one cycle is completed here. Double acting reciprocating pump gives more uniform discharge because of its continuous delivery strokes. Continuous suction and delivery strokes. It is more uniform discharge giving machine. So this is a diagram of double acting reciprocating pump. These are the advantages of These are the advantages of reciprocating pumps. The reciprocating pump requires no priming. It can be used to deliver liquid at higher pressure. It has higher efficiency as compared to centrifugal pump. It can work in a wide pressure range. Disadvantages are this has higher maintenance cost due to more wear and tear of the parts. As compared to the centrifugal pump, it is heavy and bigger in size. The initial cost of these pumps are very high. The flow rate of the liquid delivered is low. Some of the applications are like these pumps are used as a feed pump for boilers for pumping industrial fluids. These are used in hydraulic jack, firefighting applications, fuel injection in automobile engines. These are the application of reciprocating pumps. These are the references here. In further video, we'll cover the next topic of this unit. Thank you.